I am International Sales Manager for various regions, including Europe, Africa, including North Africa, and Southeast Asia as well. So we work with a series of distributors throughout the globe, and we sell through those distributors who look after all the sales, service, and application support locally. But we are always available. The international sales managers and the technical support team here are always available to support them and support you as customers when you have purchased a stable microsystems texture analyzer. So I have a small presentation which we can go through just to give you an overview of the instrument, and then I have some samples, and I have 3 tests that we can show you, or that I can show you, using the instrument, and give you some display of the software and the type of results that you can receive from the instrument. It's or I have one of our instruments here, but you'll understand that a little bit more in a second with the presentation. While the presentation is on, if you have any questions, please don't hesitate to ask. We can always try and cover as many questions as possible, or keep them till the end, and we can always review the instrument with the software or with the presentation. So let me share my screen and then go straight to the presentation. As I say, we are Stable Microsystems. My name is Paul Brown. I'm the International Sales Manager covering Europe, Africa, North Africa, and Southeast Asia. And our partner in Egypt and Libya is Atef Rizk, today represented by Mohammed. If you have any questions, you can come to me directly, or of course through Atef Rizk, who are our authorized distributor in Egypt and Libya. We're based in the United Kingdom, just south of London, a little village called Godalming in Surrey. All the manufacturing, all the design, all the support is from the same office. So everything is at hand here when we are in the office. It means that I have communication directly with all the software engineers, all the technical engineers, all the build, etc. So lots of information, lots of support is available on hand through the offices here in the UK. We've we have been around for more than 30 years. In fact, we started in 1983 when the very first texture analyzer from Stable Microsystems was designed and sold. We now have well over 12,000 installations globally. All the products are built here in the UK, designed and built here, and packed, ready for international shipments. We sell in well over 60 countries through a distribution network. And as I've already stated, Atef is our distributor for Egypt and Libya. We work in many sectors. So pharmaceuticals, cosmetics, food products, research, quality control. So it's a wide-ranging instrument, and I hope I can show you some of that today with this slideshow and with the instrument as well. Something that we are, one of the unique sides that Stable Microsystems has, and something to show you the capabilities of the instrument, is that using Google Scholar for an example, we have well over 20,000 published papers using our instrument for a wide variety of markets. As I've already stated, whether that be research and development, whether it be quality control, in pharmaceuticals, food-based products, ingredients for foods and material science, but also cosmetics, personal care. So a really wide range of capabilities from our series of instruments. I've got a couple of slides just to give you some indication of different types of customers or brands that use our instrument globally. Food-based mainly here, and I'm sure you will recognise a lot of their logos. Cosmetics industry. Again, I'm sure you'll recognise many of the logos. And just to say as well that the presentation, Mohammed already has a copy of this, but if you would like a copy, I'm very happy for you to receive a copy of this as well. And then finally, pharmaceuticals. just to give you an idea of the type of pharmaceutical companies that are using our instrument, again, globally for research and development and quality control. Sustainable Microsystems instruments. I'm going to take you through what we call the principles today. This is our range of instruments. We have 7 instruments or 7 texture analyzers in our range. They start with 2 small ones at the front, which has a maximum load cell of 10 kilos, then 50 kilograms, 100 kilograms, and 750 kilograms. That's the maximum force capability of each of the instruments. And today I will be showing you this instrument here. This is our most popular instrument. This instrument is has well over 6,000 installations globally. A lot more, in fact. I think it's actually near 8,000 globally. This is the TAXT Plus Connect. This has a maximum load capability of 50 kilograms. Depending on the application, depending on the type of samples you want to test, depending on the sample itself and the way of testing, will direct you or guide you towards which instrument is possible to use. The advantage with our instruments is they have interchangeable load cells. So even if you have a 100 kilogram instrument, you can fit anything from a 500 gram, 5 kilogram, 10, 30, 50, and 100 kilogram load cells. So up to those maximum forces. As I said earlier, we're going to run through the 7 principles, or we're going to run through the principles. We have 7 principles from Stable Microsystems. Those principles are seen on the screen here. And most tests, something I would say 99% of tests, come under one of the headings that you see here, which is compression testing, punctural penetration, tension extension, shearing or cutting, adhesion, extrusion, and bending and flexing. Again, whether you're working in food, whether you're working in pharmaceuticals or cosmetics, one of these principles generally will guide you towards the type of test that's possible with one instrument. All of these tests are possible with one single instrument. So compression is the first test, and it's probably the most common with regards to products. So compression is basically moving down towards the sample, whether you're compressing the whole sample or whether you're making an actuation force, or whether you're compressing a packaging, or whether you're doing the neutral compression of a tablet, or squashing a cake or a bread. It's a very simple, very easy type of test. I have a short video here just to give you an idea of the type of test and what happens. So the probe comes down, it's larger than the sample, so it makes a compression of the sample, and then this test in particular goes to failure, so you can see the product fails. I'm giving you an example here of a type of graph. You'll see this in the software in a little bit, but the graph is live. So as the force increases onto the sample, the graph plots and shows the force increase, failure point, and then a drop in force. This is a standard graph force time, and you're going to see a lot of that throughout the presentation. We can also do what we call multiple compression. So we do what we call bulk testing. This is where instead of just one sample, we use multiple samples to make the test. This is usually used in where a sample is irregular in shape, or regular in size, or regular in weight. So breakfast cereals, granules, pasta, for examples. These type of products are generally tested in some sort of bulk testing. The second principle is puncture or penetration. This is where we're using a probe that's generally smaller than the sample itself and penetrates into the product itself. Now, whether that's a cream or a gel, whether it's a semi-solid product, even a full solid product, we can penetrate soaps, for example, or whether it's a food-based product like a tomato or a fruit, an apple or an orange, we make a penetration into the product. Penetration is generally a small probe or a cone or a ball or a needle, depending on, again, on the type of product that you are testing. So another video This is what we call a 2mm probe, so it's 2mm in diameter. It's making a puncture into the lipstick or the lipstick to see how hard it is. Again, you can see here, this is a forced time graph. And we can see, again, what would happen is it would plot as the probe starts to enter the product. We then have a plateau area here where the product is homogeneous throughout, and we have a negative side of the product. So with one graph, with one test, we can actually test and have results of different areas of the product itself. So multiple areas with one test. So here we're showing, or we can ascertain from the graph, analyze the graph, how hard the product is, so the maximum force it's taken to make the penetration, but also when the probe returns, when it comes out of the product, we can look at how sticky the product is, how much the product is trying to reduce the return of the probe from its penetration state. So one graph can actually tell us multiple areas about the product itself. Cutting and shearing is the third principle. So it's measuring to the force required to slice or to cut through products. Now, when we say cutting or shearing, you generally regard that we're using a knife or some style of cutting blade, but actually, as a human being, we are expert shearers, because when we bite into something, whether that's a piece of chocolate shown here, or a pastry, a meat, or a vegetable, or a formulated product like a donut, we're shearing through those products. So particularly in food products, shearing is very popular, whether it's a cheese or a meat or a baked product. Blades come in very different forms and different materials. So here we're looking at what we call a blade set. This is a flat blade just shearing through a Rice Krispie cake. But we also have things like perspex or plastic blades for very soft products, for cooked fruits, etc. We also have very sharp blades like razor blades for very hard products. So maybe tablets or confectionery products that are like sugar-based, hard, sweet, can be tested using very sharp blades as well. So a variation of different types of blades are possible. Here's just showing you some plastic blades. This is for testing pastas or cooked fruits, for example. And here it mentions the AACC standard, so the American Association of Cereal Chemists. So our instrument and software can adhere to certain standards that maybe you would want to work to. So the AACC is for things like, it's for food, for pasta, for breads, but also ISO, DIN series. There's many different types of tests that we adhere to, or we can adhere to, as requirements are needed. Extrusion, we're halfway over the principles. Extrusion is looking at the consistency or the flow of product. Things like toothpaste, but it could be condiments for foods. It could be creams that we rub onto our skins or our faces, or again, food products, things like creams or gels that we potentially use and extrude through different ways of delivery. Back extrusion is a very useful and well-regarded test, looking at the consistency, the work of extrusion, the cohesion, and the extensibility of the product. Back extrusion is often used as an alternative or in synchronization with viscometer or rheology, because it gives you additional details about the product. And one of the advantages, as you can see in the video, is that the product can be tested in its original delivery container as well. So back extrusion is very popular. It's used for things like viscid liquids, sauces, gels, pastes, etc. Again, you can see an example of a graph here. Force time again. You can see increase in force as we do the penetration into the product. And then we have a large negative area, which we can also analyze to understand the product when the back extrusion is working, when it's coming back out, when the piston is coming away from the product itself. So you can start to see that one test can offer multiple areas of analysis within the software and the instrument. Bending and flexing is looking at the break strength or the fracturability of products. Usually the products are quite solid. So whether it's a biscuit or a pasta, but in pharmaceuticals, it could be a tablet, it could be some style of lipsticks, but it's looking at how quickly something fails or whether there's an elasticity to it, looking at the force distance generally within this type of product. So here we have a tablet that we're showing you to see how quickly the tablet breaks. The graph again here, this time shows force over distance rather than over time. So we can see that there is a very sharp increase in force to the failure point and a sharp decrease because the product has failed completely and there is no more applied force to the load cell. Again, multiple areas of analysis. Here we can see that this particular graph is looking at the force, which we would call hardness, but it's also at the same point it's looking at what we're calling fracturability, or in fact what we'd actually be analysing here is distance. So if something breaks very quickly like the tablet, if it has a more flexible or elastic type property to it, then the distance would obviously grow larger. So you can analyse at the same point multiple data points as well. Two more to do, tension and extension. This is looking at the extensibility or the tensile strength of products, whether that's a seal of a product or packaging, for example, or whether it's something like mozzarella cheese, looking at how at different temperatures, how it elongates or the extensibility of that product. It's possible to look at how things pull apart generally within a tensile region. Here we have a video of a child's toy, and it's a stretchy toy, looking at how that stretches. The video doesn't go to fail, but here on a graph we can see that the increase in force, at which point it fails with an immediate return, and then we can still see a line here, but this is the return. We're collecting all the data. Because we've gone to distance, the distance increases as we come away. As it fails, it reduces, and then it returns to start. So we're plotting the data at both start and finish. But again, two data points at one area, two data points that we can analyze within the graph. Extensibility would be your distance measurement, and then your resistance to extension would be your force measurement. I hope you can start to build up a picture that there are lots of different analysis capabilities within the instrument. Finally, adhesion. Adhesion is a slightly different application because we turn the graph upside down and we look at the negative side and we turn that into a positive to make the analysis. Now, with adhesive characteristics, it could be that you're looking at something that sticks to another product. So whether that's a seal of a packaging, whether it's an adhesive tape, or whether it's a sticking plaster, or whether you're looking at how sticky a wax is on the skin, or the residue of something that's left on the skin, for example. It's all possible with the texture analyzer. This just gives you a very quick review of how it's possible to do that. We bring the probe down and we apply a bond strength, which will be showing the negative. And as I say, we've turned the instrument on its head, or the graph on its head, and we look at the negative part we've turned into a positive. So as we come back up, we're looking at the graph at the top here is the adhesion point, and then we're looking at the work of adhesion and the complete debonding. So we're looking at multiple areas, 3 areas in one graph, for example. So you can start to see that there's a build-up of different types of analysis available. Also, just to point out on this graph, you can see that actually we've also shown that the force is shown here instead of grams or kilograms, we've shown it in newtons. Our instrument has the capability to show grams, kilograms, newtons, ounces, pounds, and also millinewtons. And it's on the fly, so you can actually make analysis on, you can run the graph and have the graph showing in grams, but actually the analysis can be calculated into newtons automatically for you. So that's the presentation. We call it one instrument, endless testing possibilities, because it's down to how you want to test and what you want to understand about the product. Often there's very few tests that we cannot perform using the instrument to give you some analysis of different types of products. Is there any questions on the slideshow or anything you want me to show again and run through again before I move on to the instrument and show you the software and the instrument working?
Thank you, Paul. لو في أي حد عنده سؤال بخصوص البرزنتيشن يا ريت يقول، ممكن تتكلم في المايك وممكن تكتب في الشات بوكس. لو ما فيش احنا إن شاء الله هنكمل بعرض الجهاز أمامكم وقياس عينة عن طريق مستر باول. هل في أي سؤال؟
السلام عليكم.
وعليكم السلام. دكتور سلوى.
دكتور وداد.
دكتور وداد، ازي حضرتك؟
الحمد لله، الله يكرمك. لو سمحت، انا كان الصوت بيقطع معايا، عايزه اشوف اللي هي خلاصه العمل او طريقه العمل للجهاز ده باختصار.
الحقيقه
يعني
هو الجزء اللي جاي هو هيكون شرح طريقه العمل، يعني هو هيبتدي يشرح على الجهاز دلوقتي. احنا خلصنا البرزنتيشن نظريا يعني كتطبيقات، وبعد كده هنبتدي نشرح في الجهاز نفسه.
ماشي، ربنا يكرمكم.
شكرا دكتور. هل في اي سؤال تاني؟ All right, Paul. We can continue. Thank you.
Thank you. Okay, so what I have is, this is the software package that is called Exponent Connect, and this integrates with the instrument and talks to the instrument. I also have a camera, which is directly onto the instrument. So this is me. So let me very quickly show you the instrument and then explain the instrument very quickly, and then we can start to look at tests. So this is a TAXT Plus. We have some manual controls, so we can move the arm up and down manually here. You can see the arm move up and down. We have emergency stop. We call this the base. The load cell, which makes the calculation for all the force, time, and distance readings, is in here. We have probe fitted automatically. We call this the arm, and this is the column. Excuse me. It's a very simple instrument. In regards to that, there's nothing complicated for setup, or it doesn't take hours to have ready to make a test. It's very, very quick, and I will show you that very simply. So what I've done is I switched the instrument on. It takes 2 seconds to fire up and be ready. We have some lights on the front just to tell me that it's powered up and that the comms is talking to my computer. And it will also show us when the instrument is running a test, because it will show busy and it will show red. I can start a test from the start, from the front of the instrument, or I can do it from the software. So I'll switch between the two to try and show you how the instrument works. In the software, this is a graph window. So when we run the test, the graph will actually plot in here and show us how the test has run. We can have multiple graphs laid over the top of each other, and I can show you that. At any point in the graph, we can click and we can see a force, distance, and time reading. and we can list all our graphs in here as well. We have a tab which has like an Excel spreadsheet, and when we run some tests, this will give us some data in here, some numerical data to understand about our product. You can control and you can set up tests individually from the TA settings here. We include a large number of sample projects. So if I just click into sample projects, you can see that they are broken down into different areas to try and show you where to find them. There are more than 400 applications or 400 sample projects included in the software. All are fully flexible, so you can design your test from the ground or base upwards, or you can use one of our samples and adjust that test to suit your own individual sample as well. So today I've got 3 tests that I can carry out for you. First of all, I will show you the bread AACC bread firmness. This is a good test to show you how the instrument works and how the application studies or the projects work. I also have a spreadability with some cream that I have ready in the fridge that I need to go and collect. And also we can do what we call a 3-point bend test, so a fracture test. And I have some biscuits and some tablets that I can show you as well, so you can see the differences. So first of all, let me show you the bakery. If I open up the bakery, you can see that there are lots of different types of bakery tests in here. So when you find the test, or when you understand which test you want to run, so example here is the AACC bread firmness test. If I click on here, it opens up a window which we call an application study. This basically explains exactly how the instrument is going to function, how to prepare your samples, how to calibrate the probe, a typical plot. So this is a typical type of graph we would expect to see. Any observations we made about the test itself when we ran it here in the office, how the data analysis is formed and some example data analysis, any notes that we made, and in some cases we also put some references here as well. So these are references that have run this test or used this test and used either our instrument or have used this type of test for different types of product, for example. So it could be that somebody uses it for a flatbread or a white bread or a brown bread, etc., etc. So you have all of this information included. You can print this if you want to, or you can use some of it. You can copy and paste if you're using it for papers, for studies. If you are happy with this analysis or how the test runs, we can load all of this data automatically into the software, ready to make a test. All I do is I click Reload Project. It's going to ask me a few questions quickly. I will click through these very quickly because we don't need to explain them today, but it's just asking us what do we want to do next in essence. So I'm going to say yes to that, no to that. And in the background, all of this information is being loaded into the software. So if I close it down, here we have project notes. So the notes about the sample preparation and also about the calibration are here, and the test setup. So I can close that if I want to. In the project, I can see the settings. So if I do want to change any of these settings, I can. So here, although it's a 40% strain test, so this is going to, the probe is going to move down. When it touches the top, it's going to calculate the height of the sample, and then it's going to push 40% into the product and back out again. But if I wanted to make that more or less, I have that capability, and I can do that directly here just by, I don't know, typing in a different figure. Okay, same with the test speed. If I want to make it a different test speed, I can make it a different test speed. I'm going to leave it at 40%. So 2 things that I need to do. I need to tell the instrument the product that I'm going to use. So I'm going to use a soft white bread. So this is the title that it's going to give the graph. and I'm just going to tell it where I'm going to save it. I have on my desktop, he says confidently, seminar Libya, there we go. I'm just going to put it into this file so I can always then go and find my graph. So once it's saved, I can always find the graph, and I click apply. In essence, I'm ready to do a test, but what I do need to do is just tell the instrument, because I have the flexibility of being able to change different probes, different fixtures, I need to tell the instrument where 0 value is so it can calculate the height. So if I'm going to click backwards and forwards a little bit. What I'm going to do is I want to be able to tell the instrument that this point here is 0, so that when the probe comes down onto the product, when it touches the top of the product, it presses in, it knows exactly how far to go. So what I'm going to do is I'm just going to move the probe close to the base, back to the software, just small. That, okay. So I'm going to do a calibration with the instrument. So I'm going to do TA, calibrate height. It's automatically placed the distance, the speed, and the force in place. When I say OK, it's actually calibrating, it's moving the arm, tells the height of the product. When it's finished, it says height calibration successful. So what I will do is I'll run it again, and I'll have I'll open the window very quickly after I've started the test. The TA, calibrate height. And just click in. You can see, hopefully, in the window, the probe is moving towards the base, touches the base, moves back up, and the height calibration is successful. So I know that the distance. Let's go back to here. So I know the distance between here and here is exactly 50 millimeters. If I move it, it's not a problem because it knows where 0 value is, so it can always calculate the height. So this is my white bread. Oops, put it in the window. This is my white bread. So I know that the test requires 2 slices. So I just need to move it up a little bit. So I place the samples in place, and what's going to happen is the probe will move down. It will touch the top of the sample. It will calculate the height of the sample. It will then penetrate 40%. Then it will come back out to the start position. And during that process, it will plot the graph. So what I suggest I do is I run the software so you can see the software working. And I run a second test with a second set of the sample, and then we can I can show you the video. So I'm all ready to make a test. So I go TA run test, soft white bread. Okay. So the instrument is telling me that it's running. Okay, it's telling me the motor's running and that we've got a file running here. I can show you it's moving down, and we'll get a video. We'll show the video at the same time, or the video afterwards. Okay, it's moving very close to the bay, or close to the sample. It's now just about to touch the sample. There we go. So here is the plot happening. So it's pushing into the sample by 40%. And then it comes out. So now we have our graph that we can use for analysis. If we look at the results, we have no results currently. But if I just run a quick macro, and I come back to my results, it's automatically put the data in, and it's told me that the firmness of this product, as per the AACC standard method to calculate the firmness, it's 327 grams in firmness. Okay, so we don't test the same at one sample twice. We always use a new sample. So if I do TA run test, it's automatically numbered the next test as number 2. If I start the test, show you on the camera. So the probe is moving towards the sample. When it touches the sample, it's then going to compress 40% into the product, and come back out again. So here it's compressing into the sample, and then it's coming back out. Okay, that's not a problem. So we go back to the graph. Something very odd happening. Oh, that would be why. Okay, my cable wasn't right. So let me run one more test. That one because that was not right. I'm just going to run one more test to show you. So you can see the plot happening. And then the negative side. So again, we can run the analysis again. It calculates the firmness again. And if we look, we can now see, we can understand the firmness of the product in comparison. So it's very, very simple to do. Okay, so what I'm going to do is we've run the white bread. Let me show you in the camera. What I also have is a sourdough bread. So I know from, oops, let me show you, sorry, a sourdough bread. I know from experience that this bread is much firmer in design, just the type of bread it is. So let me, this one. So 2 slices again. All I do is I go back to my software. I tell it that this is a different bread. So this is a I'm going to change it to number 1. I apply that. Okay, so I can run the test again, and you're going to see a very different analysis or a very different graph. And this is where you can start to see the differences between products or between samples, between good and bad products. Okay, perfect. These 2 graphs over each other, I can view selected only. So as a comparison, we can see that the sourdough bread, this different type of bread, is much firmer, and it's automatically, very graphically, you can see that it's much firmer compared to the white bread. So if you were doing a comparison, or if you were doing a design of a new product, or if you had changed some ingredients or something, it's very simple to be able to see graphically the difference. If what I will do is I'll just cancel that. These 2, and then run the macro on both of them. Then we can see some results, and you can see that the white bread has a firmness of 240 grams, where the sourdough bread has a firmness of 2,361 grams. A very significant difference. So you have numerical data to back up what you have as a graphical data as well. Any questions at all?
Thank you so much, Paul. Let me please summarize in 1 or 2 minutes in Arabic,
For sure.
and then I will receive questions from them. شكرا لكم جميعا الحضور. يعني ده كان اختصارا جزء من شغل شركة ستيبل مايكرو سيستمز، وهي متخصصة في التكتشر اناليسيز. طبعا في خصائص كتيرة جدا نقدر نشتغل عليها في العينات الغذائية. احنا ما تعرضناش ليها كلها في البرزنتيشن دي، ولكن احنا نقدر نعرف منكم لو عندكم اي استفسار. طبعا يعني كان في برزنتيشن بسيطة في الأول بتعرفنا كيفية تطبيق الجهاز على كل خاصية من خصائص المواد الغذائية، زي الفيرمنس، زي البنتريشن، زي خصائص الشد والضغط. طبعا يعني بعد ما خلصنا البرزنتيشن هو شرح كيفية عمل الجهاز في خاصية واحدة من خصائص المواد الغذائية، وهي الفيرمنس. الفيرمنس هو يعتبر زي فانكشن في صلابة المادة أو مقاومتها للاختراق. فعمل تيستنج لنوعين من الخبز، الخبز الأبيض والخبز البني. طبعا هنا نقدر نقارن بين أنواع معينة من المواد الغذائية في كل خاصية من الخصائص اللي بنقدر نشتغل عليها الجهاز. ولو في أي سؤال أو أي شيء مش واضح تقدروا تتكلموا دلوقتي في الميكروفون، أو تقدروا تبعتوا على الشات بوكس، أو ممكن تبعتوا لي على الواتساب أو الإيميل، وأنا أقدر أجاوبكم إن شاء الله في أي وقت. لو في أي سؤال دلوقتي نقدر نسأله لمستر باول، يا ريت يعني ترفعوا إيديكم وتتكلموا. هل في أي سؤال؟ It seems there are no questions, Paul. The presentation and live demonstration was really interesting and straightforward.
Excellent.
Everything was clear. And of course, whenever they send me any questions or inquiries, I will get back to you. And the session is recorded so that the participants who missed it, they can see it later on our YouTube channel. We come now to the end of our presentation. Thank you so much, Paul, for this informative presentation. And thank you all for attending the last session in our food analysis training. It was in collaboration between Atef Rizk Company and the Food and Drug Quality Control Center in Misurata, Libya. Thank you so much, the FDCC, for collaborating with us, organizing these sessions to all of you. And I'd like to thank specifically Mr. Noor Ramali, who helped me spread the invitation to all of you. شكرا لكم جميعا، ونتمنى تكونوا استفدتم من محاضرة اليوم ومن المحاضرات السابقة، ونتمنى إن شاء الله نشوفكم في برامج تدريبية قادمة. لو في أي استفسار عن أي شيء تقدروا تسألونا دلوقتي أو في أي وقت على الواتساب أو الإيميل. شكرا لكم جميعا. هل في أي استفسار آخر؟ All right. They are sending their greetings in the chat to you, Mr. Paul. Thank you so much.
Thank you very much.
All right.
Okay.
You're welcome.
If there are any questions, please don't hesitate to email them in, and we can answer. And as I said, you have a copy of the presentation, so if you would like to send that out, you're more than welcome as well, Mohammed.
All right, Paul. All right. Thank you so much.
Absolute pleasure.
Okay. Okay. Thank you all. Goodbye.
Jenna, have a good day, everybody.
Thank you. Thank you.
Goodbye.
Thank you all.
Thank you.